Yeah. All right, guys, here we go. Oh, am I even ready? No, I'm not ready. All right. So we started the beginning of chapter 2 working with relations and functions. So I hope, because I drilled you pretty good about what the definition of a function is, I hope you remember. I hope you guys are literally in your 50s one day helping your high school child when they don't understand functions and you all draw them this. The function machine. It is literally a machine. Something gets plugged into it and something gets spit out of it. Normally they name a function. I'm going to call it F. F's popular, G's popular, H is popular, and so on. You are working with X's and Y's on a graph. Which variable was always the one you plugged into the function? X always went in. Then there was some type of like mathematical rule that lived inside of the function. Let's keep it simple. 2x plus 5. So you plug an x in, you times it by 2, you add 5, and then the function spits out the answer as which coordinate? Y. And then you could build all these ordered pairs, x went in and y came out, and then you could use notation that somebody went to function f, they plugged an x value in, f of x, and then it spit out the y coordinate. So when they talk about function notation, x goes in to function f, and it spits out y. And then, when they talk about f of x as a whole, which coordinate does f of x represent? Y. So just remember that. I hope everybody remembers that. All right, so guys, I have given you function f. When you plug an x in, this is f of x. This is what will happen to it. This is the rule that lives inside of that function. So if I ask you to find f of -4, what do you have to do with the -4? Plug it in for who? X. Whoever is inside of these parentheses takes x's place in your function. This would be like you plugging in a -4. So plug it in for all of the x's. So guys, the x is being squared, but not the negative sign. So the negative sign stays outside. I plug -4 in, and I square it. And then it's plus 3. I plug -4 in for x, and then I minus 9. Now, you can either PEMDAS that, order of operations, yourself, or you can plug it into the calculator the exact way I wrote it and hit enter. So plug it in or PEMDAS it, do what you got to do, and see what number comes out of function f when -4 gets plugged in. If you're not practicing it on your calculator, please don't complain if you get this question wrong on the quiz. Don't do it. It's in the negatives. It's close to my age. What do you got? -37. There you go. So now on Delta Math, you're probably just going to have an answer box. You just type -37 in and you call it a day. When we were doing it, we said we could write our answer a couple different ways. We could say f of -4 equaled -37. I like that because it tells the story. It says somebody went to f, they plugged in -4, and -37 came out. Or you could write your answer as an ordered pair, right? Function notation can always be translated to an ordered pair. -4 went in as x, and -37 came out as y. All right, well, guys, this tripped some of you guys up, and I think it's just you guys moving too quickly. Two things can happen with a function. One thing is they give you an input, you plug it in, and you find out the output. Or they reverse it. They give you the output, and then you got to figure out who the heck went in. So look at question number 2, because it's not written the same. It says, given the function g of x equals that. So this is function g. You'll be plugging x in. Here's the written rule that would live inside of the machine. They ask you to find who? X. And x is the input. So they're not giving you an input. They're asking you to find the input. The input is going to be your answer. So they want you to find x. If g of x, somebody went to g, plugged in an x, and they got -17 to come out. So is -17 an input or an output? He's an output. So guys, he came out. You got to figure out what made your rule equal that output. So you got to take your rule, set it equal to your output, and solve for x. You got to figure out who went in to that rule to make negative 17 the number that came out. So when will negative 3x plus 4 equal negative 17? This got a lot of you on the quiz because you're just going through the motions and you're like, oh yeah, negative 17, I'll plug it in. But it's not an input, it's an output. So now you have to set it equal and solve. And now luckily that's pretty easy. Everybody get x by itself. And you end up finding out that x had to be who to make that true? 7. X had to have been a 7 that went into that function to make negative 17 come out. Do you guys remember doing that? Yes? So I feel like a lot of students got that part wrong. Everybody just wanted to plug it in. You got to look at what they gave you. Either they give you an input and you find the output, or they gave you the output and you have to find the input. You got to know the difference. All right. Well, when you're dealing with functions, you always have to start with a relation. A relation is just a correspondence between x and y values, a relationship between x and y. And then there was some vocab that went along with it. The domain of your relation or function were always the what values. The x's, the ones that went in. And then the range of your relation or function was always the y values. Perfect. So now guys, if you remember, sometimes if they asked you for the domain, you were literally just making a list of x values. And then if they asked you for the range, you were literally just making a list of y values. But then sometimes there were so many x values and so many y values that you couldn't possibly list them all. And then you had to write that sandwich inequality. They had to be a number in between two numbers, little number, less than symbol, big number. That should ring a bell. All right, so just be careful with that. And then we saw that the whole definition of a function said that a function is a relation where which variable doesn't repeat? X, right? I think it was the first time I cursed at you guys. I think I said, we don't give a shit about Y. We just care about X. Yes?
My gym teacher almost broke me up today.
Did you curse? Is that why you almost broke everything up? What curse word? What letter did it start with, Chris?
Huh?
What letter did your curse word start with? That's like the mother of all curse words. You can't say that.
It was my first loss.
Mhm.
The fourth square volleyball.
Oh, and you got a little heated?
Sometimes
Sometimes you need it to emphasize the emotion. I get it, but listen, you can't do that. My poor ears can't hear it. But that's okay. I'd be upset too. All right, here we go. So remember, we don't want X to repeat. And the reason we don't want X to repeat, and I hope everybody remembers this, is that the whole point of a function is that when you plug one number in to that function, how many numbers is he capable of spitting out? Just one, right? Like if we plugged in 2, 2 would go in, 2 times 2 is 4, 4 plus 5 is 9, it would spit a 9 out, right? And then it makes the ordered pair, 2 went in and 9 came out. The function says that when 2 goes in, only 9 can come out. So if all of a sudden you're looking at a list of ordered pairs for this function, if this was listed, now it's saying when you plug 2 back in, what number comes out? That's not okay. That's not a function. When 2 goes in, only 9 can come out. So if you're looking at a list of ordered pairs and the x's repeat, that means they have different y's. And that means that this number can spit 2 different numbers out, and that ain't no function. So that's why we always look to make sure that the x's aren't repeating. Make sure that this x value only has one y value that can come out of that function. All right, and then let's look at number 6, and I think oh, I have my mouse. I keep forgetting.
I forget about the graphs.
I know, I'm telling you, you guys killed this quiz though. It's gonna come back. All right, so first, we know that in order to be a function, your x's can't repeat. So number 6 says, determine if the graph is the graph of a function. If it is a function, find its domain and range. Does anybody remember the quick test that we had to make sure that it was the graph? The vertical line
That was what it was.
You can look at a graph and you know it's a function if it passes the VLT. If you can draw a vertical line anywhere over its graph and it only hits the graph one point at a time, that's a function. That's proving that the x coordinates did not repeat. So guys, does this graph pass the vertical line test? Yeah. Now let's say the graph did this. Does that pass the VLT? No way. That means when this x goes in, that y, and that y can come out. That ain't no function. This one passes the VLT. So that means it's a function. All right, well, now that we know it's a function, let's find its domain and range. The domain are the what values? X's. Guys, can you sit here and list for me every single x coordinate that lives on this line? No, there's all those decimals and fractions in between, right? If it was specific dots, we could list them. But when the dots were connected, we didn't have enough time to do that. So all you have to do is say what x values they are all in between. So guys, how does x go on a graph? Left to right or bottom to top? Okay, so you tell me right now, what's the farthest left this graph ever got to? What's the farthest x value? Negative 11. Now remember, it's not necessarily dot to dot. It's literally how far left, how far right, how low, and how high. All right, now what's the farthest right we got to? 8. So you have to tell me that x can be any number in between. As long as you tell me that x is any number in between negative 11 and 8, you've covered all your bases. So the sandwich inequality, guys, it was always little number, always a less than symbol, your variable, a less than, and then your big number, every single time. So who's the littlest number x could be? Always a what symbol? What variable does domain talk about? X, always a, and then who's the big number? 8. Now, then you have to go back and you have to decide whether or not to put lines under these symbols. Well, hold on one second, Chris. When I did this in second period, the glare was so bad that I thought these were open circles. They're not, they're closed, but let's pretend they're open. Let's pretend they're open so that we can practice what happens at an open circle. So guys, if it's an open circle, that means the graph is going right up onto that x value of negative 11, but is it actually included as a point? No. So that means if it's not really included, do I want to say that x is greater than negative 11 or x is greater than or equal to negative 11? Just greater. So no line under your symbol at an open dot. You're not actually including it. And then the same thing here. When we get to that x value of 8, if that's an open circle, is 8 actually included? No. So you just want the less than symbol. You don't want the line under it. That is the only time you don't put the line, is if there's an open circle. Everything else will get a closed circle, a line underneath. So if it's a closed circle, or if it's a line that goes through the graph right there, that's going to all count as an equal to symbol. All right, Chris, question? Or did that kind of get talked about?
No, I can't.
Oh, sorry. Okay. Now we're doing the range. The range of the what values?
Why?
And the y's go how? Up and down. So find me the lowest spot this graph ever, doesn't have to be a dot. I'm talking the lowest spot it ever got to. Negative 7, right there. All the way up to what's the highest it ever got?
4.
So your y values have to be a number in between negative 7 and 4. Okay, who's the little number?
7.
Always a. What variable are you talking about with range? Because Delta Math will mark you wrong. Y, always a, and then big number 4. Now go back and decide. Guys, at negative 7, it was just a line. It was a line that the graph went through. So that means it's included. It's a point on that line. So since it's included, do I want a line underneath that symbol? Yes. And then up here, same thing. It didn't show any point, but guys, as long as it's a point that's going through a line that is passing there, that might as well have been a filled-in circle. So that means that 4 is included as well, and you also want a line under that symbol. So the only time you don't want the line underneath the symbol is if there was an open dot. Okay, do you guys remember doing that? Yes?
Yeah.
All right, last question. These are my favorite, and I'm telling you, you guys killed this quiz. If they don't give you a function with a written rule for you to plug numbers in and out of, then they're going to give you its graph, and you're going to be able to read the information from his graph. So this says, given the graph of a function f, find the following. First of all, how do you know that's the graph of a function? Passes that VLT, doesn't it? Okay. So it says, find f of 2. Guys, if you were going to find f of 2, that means 2 has been given to you as an x or a y value. X. So they're saying somebody's going to plug 2 in for x. So go to your graph and find where x is 2. It's right there. Now, Find me a point on this graph that has an x-coordinate of 2. Right there. This point right here has an x-coordinate of 2. So according to this graph, when the x-coordinate is 2, the y-coordinate is? So that means when you plug 2 in, who does this function spit out? -9. And we don't know why. We don't know the rule. We don't know what happened mathematically to make it happen. We don't care. That's what the graph says. All right, what if it says, find f of -8? Again, -8 is given to you as a what value? X. So find where x is -8. It's right there. Now find me a point on this graph that has an x-coordinate of -8. It's right there. So when x is -8, who's his y-coordinate? That means -5 comes out. Okay? So when they give you an x, the answer is y. Now look at the last question. Find all values of x such that f of x equals -4. Guys, who'd they ask you to find? So one of your answers are on the x-axis. Your answers are x values. You want to find x such that f of x. Who did we say f of x is as a whole? Y equals -4. So you have to find the points that have a y-coordinate of -4. If -4 was the output, what x went in? Well, guys, isn't this where y is -4? So this point right here has a y-coordinate of -4. Who's his x-coordinate? That means when x is -3, a -4 will come out. And then is there another point on the graph that has a y-coordinate of -4? Right there, when x is -7. And now those are the two x values that will make -4 come out. You guys really did well on this quiz if this is coming back to you guys, okay? All right, so your first review is going to review all of that with you. Tomorrow's review is going to review the graphing inequality with this line is shaking, which hopefully is fresh in your mind. And then we have to review writing the equation of a line. You guys did not like that on the last quiz. Well, I shouldn't say all of you. Some of you did perfectly fine. All right, but that'll be tomorrow's review. So let's get this done today. I have it due tomorrow night like a normal homework. I would try to get it done now, get it done so that tomorrow you can worry about tomorrow's review. Okay? Yes?
Does this work on your phone?
What's it again?
Does
It does. It works pretty nicely on this sheet. It's small. Yes. So you have a Chromebook or you have a phone to work on your review right now. I'll answer 1 or 1,000 questions. Use me if you need me. I would love to help. Yes. Yes.